Hello again, grade 12s. In this video, we will learn how to determine the equation of the regression line. It's also known as the least squares regression line or line of best fit. We will use our calculators to determine the equation of the regression line, so please have them handy. You will recall that the equation of a straight line is equal to y equals mx plus c, where m is your gradient or slope and c is your y-intercept. Your calculator represents the equation of a straight line as follows: y equals a plus bx. B in this case is your gradient and a is your y-intercept. You will now need to put your calculator into stats mode. If you're not sure how to do that, turn to page 332 of your Clever Maths textbook. Alternatively, I'll leave up instructions at the end of the video for your reference. You will now need to plug in these values into your calculator for you to be able to work out what your A, your y-intercept, and B, your gradient is. Once you've done that, you will find that B is equal to 6,88 and A is equal to 5,67. Writing it into the equation form, y hat is equal to 5,67 plus 6.88, and that is the equation of the line of best fit for this data set. Now, you will need to then draw the line of best fit on the scatter plot. We can use our y-intercept, right, which would be 0, semicolon rather, 5,67. I've indicated the point on my scatter plot and I've marked the coordinates. I would then now use my mean point. Our mean point is your x bar and y bar, basically the mean of your x values and the mean of your y values. We basically have to add all the x values together from 1 all the way up to 12 and divide them by 12 to get the average of the mean. And for the y values, same thing. We would add them all together, okay, and divide by 12 to get the average or the mean of these values. So once you have done that, what you get is the total of the x values is 78, and we need to divide that by 12. This would give us the mean value being equal to x. For y, the total would be equal to 605. If we divided that by 12, our answer would be approximately equal to 50,42. I will now plot this point on my graph. So it's 6.5 and 50,42. So that is the approximate position of the point. I now have to connect these two to create my line of best fit. Part C and D require us to use our line of best fit to estimate the number of books sold in the 11th month and the 13th month. So for part C, this is an example of what interpolation is. And for part D, that's an example of extrapolation. Okay. So why is this interpolation for the 11th month and why is it extrapolation for the 13th month? Now, from your data set, we see that it runs from 0 to 12, right? So anything between those, between 1 and 12 actually, that is within your given range. That's within the data set you were originally given. The 13th month, however, is outside the number of months that you were given. So that would be extrapolation. So for part C, where you see the x value or x variable, you would have to substitute in 11. and then get the answer. Then for part D, all you have to do again, where you see X, you substitute in 13 and you would get the required answer. The number of books sold in 11 months is approximately equal to 81 books. And the number of books sold in 13 months is approximately 95 books. The instructions I've placed here are for the Casio and the Sharp calculator.